This is perhaps the second most common electronic component after the resistor. The capacitor is used to store energy and can be charged using any DC source. After charging, the voltage on the capacitor will be equal to the voltage of the source. If you connect a charged capacitor to a load, it will release the accumulated energy. The amount of energy, or rather, charge per unit of voltage that a particular capacitor can store is called capacitance. The higher the capacitance of a capacitor, the longer it can power the load. Capacitance is measured in farads, a unit named after the English physicist Michael Faraday. 1 farad is very large capacitance, so in electronics, microfarads, nanofarads, and picofarads are commonly used. For some reason, a unit called millifarad is typically not used when indicating capacitance. You can, however, find it in measuring instruments, a multimeter for example. So when measuring capacitance, do not confuse it with microfarads. By design, a capacitor consists of 2 conductive plates. Between them is an insulating layer, also known as dielectric. The dielectric has a certain maximum voltage that it can withstand. When exceeded, an electrical breakdown occurs. So the second most important property of the capacitor is the voltage rating. Along with capacitance, it is always indicated on its body, and in no case should it be exceeded. In a way, a capacitor is similar to a rechargeable battery. But the essential difference is that a capacitor stores the electrical charge directly, while a battery first converts electrical energy into chemical energy, stores it, and then, when discharged, performs the reverse conversion. On the other hand, capacitance of a typical capacitor is significantly lower than the capacity of a battery, so capacitors, as a rule, are not used as power supplies. At the same time, they are simply indispensable as filtering devices, and in most circuits, they can be found connected in parallel with power supply. Such capacitors ensure stability, minimize voltage transients, and may temporarily take over the power of the circuit in case of short-term voltage drops. In this situation, a parameter called PSR is of vital importance. PSR stands for equivalent series resistance and is a value representing the loss of useful energy in a circuit. ESR is a value that shows how fast a capacitor can deliver energy to a load and is measured in ohms. The lower the ESR, the higher the performance of the capacitor.